Here's how to solve the inclined plane problem. In physics, an inclined plane is basically just a ramp. We're going to take our ramp and we're going to put a block on it. In this particular case, the block remains motionless, which means the acceleration and the velocity are both 0. To draw the forces, we start with a dot in the center of the block. We know the earth is pulling it down. We call that the weight, and we label that mg. We know that the ramp is pushing perpendicular to the ramp. We don't quite know how long that one is. We do know that's perpendicular. We call that the normal force. We'll label that little n. And we know there's some frictional force that is up the ramp, causing it not to slide down. We don't quite know how long it is. We'll call that F. When doing an inclined plane problem, instead of using your axis parallel and perpendicular to the board, we use an axis that's parallel and perpendicular to the ramp. So we're going to label our xy axis parallel and perpendicular to the ramp. Now we're going to break up our weight force into its component parts, one of which is into the ramp, the other which is down the ramp. Since the acceleration is equal to 0, the forces need to balance. Therefore, the normal force has to balance out this force. It's a little too long. Make it a little shorter. The frictional force has to balance out this down the ramp component. Now all our forces balance. To solve for the values of the forces, we have to examine the ramp. We see that the ramp makes an angle theta with the horizontal. Looking at the trigonometry here, we see that this is a 90-degree angle, so this must be the complement of the angle theta. If we look over here, since this is a 90-degree angle, and that's the complement, this one here must also be angle theta. So to find out what these values are, we use our basic trigonometric relationships. To find this side down here, we'll call it the opposite side. We know that the hypotenuse is mg. The relationship between the opposite side and the hypotenuse is related by the sine of the angle. Sine of the angle is equal to the opposite side divided by the hypotenuse. So the opposite side is equal to mg times the sine of the angle theta. And the way we talk about this, the one that's next to it, we call the adjacent side. We know the adjacent side and the hypotenuse are related via the cosine of the angle. So cosine of theta is equal to the adjacent side over the hypotenuse, which is the weight. So the adjacent side is equal to mg times the cosine of the angle theta. So now if I wanted to solve for the forces, I know that the normal force could be equal to the mg cosine theta. The frictional force could be equal to the mg sine theta because all the forces balance. What would happen if we remove the friction? The block would accelerate down the ramp. If the block accelerates down the ramp, because we remove the frictional force, can we figure out how to find the value of that acceleration? Now when you look at your force diagram, the forces are unbalanced. The unbalanced force is this down the ramp component of the weight. We know according to Newton's second law, the acceleration is equal to the net unbalanced force over the mass. This block has a mass of m according to mg. So the acceleration is equal to the net unbalanced force, which would be the mg sine theta all over the mass, which is m. So for this problem, we have with this simple expression, the acceleration is equal to g sine theta.